Welcome to the lecture Digital 3D Documentations in Archaeology. In this lecture part, we want to learn the fundamentals in the use of multicopters. Here we see an overview of the topics we want to discuss in this lecture. This should help us later to find the individual topics more quickly. Multicopters in archaeology. How do they work? Where are they used? What should be paid attention to? The use of multicopters for the creation of 3D models, orthophotos, or the recording of photos or videos from special perspectives has become an essential part of the archaeological documentation business. Commercially available multicopters are equipped with increasingly powerful cameras, are becoming less expensive, and are becoming easier to operate. This ease often leads to relying on the hardware and not properly assessing dangers. Also, the knowledge after insurances, ascent permissions, and the valid flight regulations are often few or not at all present. For this reason, it is important to first become familiar with the technology and to know the risks in use. In this part of the lecture, we want to learn the safe handling of the tool multicopter. Here, just knowledge of how it works and regular flight exercises are the key to successful use. This training program for the certificate Archaeocopter Pilot has been successfully carried out nationally and internationally by the Archaeocopter team of the University of Applied Sciences Dresden over the last almost 10 years with hundreds of participants. So let's get started on how to use multicopters. With the development of the mechanically simpler so-called brushless motors, more power can be provided with the same size compared to brushed motors. Multicopters are usually operated with batteries that supply DC voltage. Here, the lithium polymer battery, also known as LiPo, is very often used. Brushless motors are electric motors that can operate with direct current and are driven by permanent magnetic fields. This makes the energy supply much easier. However, since we are dealing with flying machines that not only contain batteries that can explode under certain circumstances, but can also drop people on their heads at high speed or cause traffic chaos, safety is the number one rule here. The three most important rules when using multicopters: safety first, and safety first. The development of multicopters is progressing faster and faster, especially in terms of operability. However, in the safe handling of this equipment, it is essential to control the device at all times, even without all the comfort functions, and to land safely in an emergency. Only with this approach, we are able to better understand the safety concepts and methods, and in case of emergency, we can correctly assess the situation and keep control of a multicopter. Let's talk about the rules when handling multicopters. Whatever legal regulations apply at the location of the planned flight, the following rules should always be taken into account as a minimum. The flight area must be secured and all participants involved must be informed about the planned flight. When flying, the pilot must keep an eye on the multicopter, maintain visual contact with it, and must not allow himself to be distracted. A co-pilot should at least be present to shield the pilot from any outside influences and to take over communication if necessary. Flying must only be done in a recovered, healthy state without the influence of drugs. Flying over people, animals, or road traffic are of course prohibited. Flying is prohibited in nature reserves or other places of rest or even safety, such as public buildings, hospitals, or accidents. Photography of buildings for documentation purposes is only possible with written permission. The transport of dangerous goods or the dropping of objects is prohibited. These rules should actually be self-evident. We will come to the specific legal provisions that partially reflect these rules in a moment. A multicopter, as the name implies, has multiple propellers. Unlike a helicopter, which usually has one large central rotor and a vertically extending small rotor at the end of the tail, Most multicopters have 4 rotors. There are certainly special designs that focus on issues such as fail safety or maximizing payload, but those will not be the focus here. We will focus further on the safe handling of common multicopters with 4 rotors, the so-called quadcopters. Due to the given symmetry, the mode of operation is quickly apparent and easy to understand. To understand how changes in the different motor powers affect the flight behavior of a quadcopter, let's take a look at this figure. At the top left, we see how a quadcopter works. 2 diagonally opposite rotors each turn in the same direction. At equilibrium, just enough force is applied to the motors to keep the copter balanced and not moving. This is certainly a theoretical ideal case, as even small influences from wind or slight differences in force of the motors or changes in the propellers can cause the quadcopter to move. Below we see that with less force, shown here in blue, the height of the copter decreases, and correspondingly with more force, shown here in red, it increases in height. To the right, we see that if 2 motors turning in the same direction receive more force, and in the same turn the other 2 receive slightly less, then the copter will turn in the opposite direction. To move in the plane, we bring the quadcopter in a certain inclination. To do this, to the desired direction of flight, the rear motors in each case receive more power. In the figure we see 8 typical directions, but by a proportionate force allocation, any directions can be realized here. In order to safely control multicopters in the air, recognize their orientation, and be informed about the current state of the system, the flying machines communicate with the pilot in a variety of ways. First, a color scheme of the multicopter can help us to identify the orientation of the aerial device. LED illumination underneath the multicopter and on the control device, as well as LED color codes used, tell us the current state of the system. In addition to the visual signals, there are also acoustic signals. Underneath the DJI Phantom II are highly visible LEDs that can glow in green, yellow, and red. The combination of a color pattern and frequency allows the current state of the multicopter to be seen from the ground. For example, the copter will slowly start flashing red when the battery in the copter is below the first low voltage mark. The remote control also communicates with the pilot. Since batteries are also required there for operation, the remote control begins to draw attention to this with a rapidly flashing red LED. In parallel, a regular fast acoustic beep is triggered. Here we take a look at a DJI Phantom II multicopter. On the left we see a possible equipment for use with enough batteries, a GoPro memory cards, a GPS dongle to record the flight path positions, an anemometer to measure the wind speed, and a high visibility vest. Here you can also see that the multicopter has been painted black on the back. This allows the position and orientation of the copter at a distance of more than 100 meters from the pilot. At further distances, the orange ball can be mounted, which increases the detection up to 150 meters. This is what we see the multicopter in the big picture during the operation in Bukhara in Uzbekistan 2015. The position of a multicopter is preferably determined by a GPS sensor. With the DJI Phantom IV, distance sensors are added, which enable a much more stable position in space. A compass is still necessary for navigation and orientation of the position. Therefore, one of the 2 important phases is to prepare the device so that the GPS signal has been reliably received, and to calibrate the compass before each flight session. For compass calibration on a DJI Phantom II, the copter is brought into the calibration state by moving the switch on the top right of the remote control up and down several times. The multicopter signals this by a constantly lighted yellow LED. Now 2 rotations of 360 degrees take place, once around the Z-axis and then around the X-axis, with the copter turned 90 degrees on its side. After each rotation, the copter signals the calibration status. During the warm-up phase of the DJI Phantom II, The position is determined via GPS and saved as a home point. During this warm-up phase, the LED color pattern changes from yellow to green. This means that the aircraft is ready for operation. Homepoint refers to the position to which the Phantom will return if the connection is lost. If the position is stored during takeoff in GPS mode, the Homepoint can be reset by quickly changing the S2 switch 5 times on a Phantom II. The start should only be performed after the Homepoint has been saved. Let's take a look at a few reasons that can lead to a connection failure. First, the remote control is turned off. Second, the remote control is switched on and switch S1 is set to Failsafe. Third, the aircraft moves out of range of the transmitter, and this is the most common case. Fourth, an object prevents communication between the remote control and the aircraft, reducing the signal. And fifth, a malfunction causes signal problems with the remote control. If we are aware of these reasons, we may be able to regain control during the failsafe go home and land the copter on our own. If a disconnection happens, then an automatic landing occurs. This happened if the multicopter is ready to fly, but the flight is not GPS assisted, or when the copter is ready to fly, it flies with GPS support, but the GPS signal fails for 20 seconds. It is clear that if the copter is operational and can locate its position in space by a GPS signal, that a go-home operation with landing is possible. If there is a loss of connection between the remote control and the multicopter during flight, but the multicopter is still ready to fly and continues to receive a GPS signal, the copter will change to the color yellow and remain in place in the air, signaling a warning. If the connection persists for more than 3 seconds, it will change to go-home mode and initiate the flight home. In go-home mode, there are 2 scenarios depending on the current altitude of the multicopter. If the flight altitude is higher than 20 meters above the takeoff point, the multicopter flies directly above the home point, descends to a flight altitude of 20 meters, and stops there for the time being. If the failure scenario occurs at a flight altitude below 20 meters, it will first fly up to 20 meters and then fly directly over the home point. At this point above the home point, the multicopter dwells for about 15 seconds. If the pilot does not abort the failure scenario during this time, for example to land, the multicopter will start landing and then switch off there. Here, there is a high risk that the multicopter will land on an uneven surface, tip over and possibly suffer damage. To abort a failure scenario, we can change the switch on the upper right side of the remote control, which is normally set to off, to one of the other 2 positions. If the connection is available, the pilot can control the copter again and land on his own. If the switch is already at one of the other 2 positions, then control can be regained as soon as the connection between the copter and the remote control is re-established. When the voltage in the battery in the Phantom II reaches a residual voltage of 30%, the copter will start the first low voltage warning. For this purpose, it slowly starts flashing red. If a residual voltage of only 15% is reached, then the second undervoltage warning begins. A fast red blinking on the multicopter and the automatic landing procedure is initiated. After landing, the throttle stick should still be pressed down for a few seconds. It is advisable to initiate the landing procedure already after the first low voltage warning in order not to endanger the device and the control. Furthermore, the battery contacts should always be kept clean to avoid connection errors. The Phantom II is definitely a very good device to test these fail-safe scenarios, to understand the communication between pilot and multicopter, and to train yourself in the use of a multicopter. But now we want to start looking at how to do professional documentation. This goes hand in hand with better equipment and more comfort. In our projects, we have lived through all generations of multicopters from DJI. With the 4th generation, documentation with a Phantom has ushered in a new era in the field of still relatively inexpensive multicopters, which on the one hand attracted attention with their compactness, but on the other hand with an excellent control concept and a high-quality, stable camera copter system. To this day, the DJI Phantom IV is a very common tool in documentation campaigns. It is even equipped with its own flight simulator. This can be used to refresh flight skills before documentation missions. A special feature is the camera mount, which, together with the camera, enables particularly high-quality recordings. Furthermore, infrared, stereo vision, and ultrasonic sensors are installed, which enable localization above ground and thus very stable flight behavior. There are also optional distance sensors to the front, rear, and sides to avoid collisions. As already mentioned, the DJI Phantom IV also has a status LED. A special feature is the camera suspension, which enables particularly high-quality recordings together with the camera. Furthermore, infrared, stereo vision, and ultrasonic sensors are installed, which enable localization above ground and thus a very stable flight behavior. There are also optional distance sensors to the front, rear, and sides to avoid collisions. With the DJI Phantom II, we saw that there was a particular focus on the capacity still available by measuring the current voltage of the batteries. It is clear that this is an important criterion for safe flying with multicopters. The display concept for both the flight batteries and the remote control has improved significantly and can be quickly measured in percentage terms by 4 LEDs. In this table, we can read the remaining battery capacity available by the LED codes displayed. When a lamp is on, we indicate it by the dark square, and when it is blinking by light square. When an LED is neither blinking nor lit, it is represented by a minus. The 4 visible LEDs indicate the remaining capacity for both the multicopter battery and the remote control battery. The range can be seen as a percentage in the last column. The remote control is considerably heavier and equipped with further technology. For example, there is a return home button that immediately activates the go home scenario. Since the remote control has a complex, elaborate inner workings, it also requires more power. Therefore, the remote control can be recharged in the same way as the batteries and shows the remaining voltage via LEDs. Furthermore, there are controls for camera adjustment, change of flight mode, video and photo recording, and various connection options. For almost all multicopter versions, stickers are offered commercially for the remote controls, which once again compactly display the functionalities and important status messages. A display, for example a smartphone or tablet, can be attached to the remote control for controlling and displaying the video and photo data. There is also a variant that can be purchased with the display already mounted. The available settings of the copter, the recordings, and information on the display are very extensive. There are a system status, obstacle status, flight mode, battery level, flight telemetry, GPS signal strength, remote control and live video signal strength, settings, photo, video, gimbal, live stream, overview map with takeoff position and position of the copter, automatic takeoff, landing, and much more. On the one hand, this simplifies the handling significantly and also improves the quality of the recordings. On the other hand, as a pilot, we should always keep an eye on the multicopter in flight, which is hardly possible due to the required controls on the display. In critical documentation flights, it may be necessary to have a co-pilot with you. Since it is often very difficult to recognize the copter as a small dot in the sky, the co-pilot can keep an eye on the copter while the pilot concentrates on taking pictures. Should a dangerous situation arise, the pilot and co-pilot can fly the multicopter back together or bring it safely to a landing. What about the care and the storage of the batteries? As the batteries for multicopters become more complex and intelligent, the price also increases. For a sensible flight, often several batteries are needed, which should work reliably. In addition to this cost factor, the safety factor should not be underestimated. A battery can burn or even explode under unfavorable circumstances. The chemical composition of the batteries varies depending on the battery type. Therefore, If damaged or handled improperly, they can release toxic gases, cause lasting damage to the multicopter, or lead to burns or chemical burns in humans. A cooled battery often needs a longer time to charge. For the battery of the DJI Phantom IV, for example, it is 1 hour 15 minutes. The charging cycle should not be interrupted. Afterwards, the battery must cool down again and rest for a certain time before it can be used in the multicopter. If large area flights are required virtually in piecework, a good battery strategy is required here. In the case of the 2018 documentation campaign in Mongolia, where several square kilometers were imaged in just a few days using 2 Phantom IV, sophisticated battery charging management was required in addition to elaborate planning for the flight. A power generator provides the necessary energy to recharge the batteries. The charging system can be seen at the top right. All steps are recorded in a protocol. A battery that has just completed a flight is cooled down for at least 1 hour. Afterwards, it can be hung up at the charging station. After charging, it has 1 hour to cool down again. There are suitable fireproof bags for every type of battery. The use of these bags is standard and in some cases even mandatory. The batteries should be transported in such a way that nothing bumps against them. Here it helps to imagine a battery as an egg carton and to handle it accordingly. It should also be noted that rechargeable batteries only like certain temperature intervals. For example, batteries should not be exposed to frost or high heat. These data must be noted immediately when buying the batteries and always taken into account. A smaller temperature interval may apply to the use of the rechargeable battery, and this must also be ascertained in advance. In order for the batteries to last longer, they should not be stored empty or fully charged. The batteries of the DJI Phantom IV bring themselves after a certain time to a storage voltage of 50–60%. After half a year at the latest, the batteries should be fully charged and checked again. Unfortunately, the batteries of the DJI Phantom IV are suspected of having a built-in maximum recharge count of about 200 charges. After that, they are unusable and must be disposed of. Therefore, it is worthwhile to clearly identify the batteries from the beginning and record the charging cycles. The unique identifier can often be determined by the last numbers and letters of the series identifier. If each flight is recorded, the battery used can also be noted there. This can then at least reduce the likelihood of an unpleasant surprise after a long journey to a documentation campaign. What about the disposal of the batteries? It is important to know that batteries and rechargeable batteries do not belong in household waste, but must be taken to appropriate collection points and disposed of in accordance with regulations. To prevent short circuits when disposing of several rechargeable batteries, contacts should be insulated, for example using adhesive strips. After listening carefully to this lecture, answering the following comprehension question should help you to summarize the most important statements again on your own. The practical part is about getting to know the Meshroom software and processing a first dataset. Here's a little guide to Meshroom in 4 steps and what the end result should look like.